Hello, students. Today we'll be working on applications of logarithms. We're going to look at two formulas. The first one is the value of either appreciation, which is growth, or depreciation, which is decay. And you'll see that growth is going to be handled with a plus sign. Decay is going to be handled with a minus sign. These are what the different variables stand for. And we're going to look at this first example. So we have a new car valued at $21,500. It depreciates at a rate of 20% per year. So we'll take the formula V equals P times 1 minus for the depreciation, R, and then to the nth power. We're first of all asked if the loan is for 4 years, how much will the car be worth when he makes his last payment? So looking at our information, the purchase price of the car is what P stands for, $21,500. The rate is the percent. Now, 20% is, here's the decimal. We have to move that 2 places to the left, so 0.20. Your number of years in this problem is 4 years. So n will equal 4, and our job is to find v. So v equals P, which is 21,500, times 1 minus for depreciation, the R as a decimal, so 0.20, and then the exponent is a 4. Now, you can calculate this. All of these values are filled in. So we can just run this through on Desmos and do the calculation. So 21,500 times 1 minus 0.20, close that parentheses and raise it to the 4th power. And you'll see that we have 8,806 and then 0.4. Now we'll look and see how this is asking us to write the answer. Since it doesn't say, and this is about money, we'll go ahead and make it look like dollars and cents. So the volume, let me get this back to a regular mouse, will equal $8,806.40. That would be the value of the car. So it started at $21,500. It ended at $8,806.40. Okay, then our second part of this uses the same P and R, and so it tells you to do that right here, and it gives you a new value. So it's wanting to have us calculate how long it would take, how many years, for the new value to be 7,000. So how long would it take to depreciate to 7,000? All right, so now your formula is 7,000 equals 21,500. That's the same p-value that we had before, times 1 minus the rate, which was 0.20. And this time, your variable is the exponent. Whenever that's the case, we need to try to get this base by itself, which means the first thing that we're going to do is divide by this number in front of the parentheses. So we're going to divide by 21,500 on both sides. And so you may need to do that on Desmos. So take 7,000, divide by 21,500. And we may need to write down quite a few places of that decimal. So 0.32558. I'm going to write down all of those. 0.32558. 0.32558. You could write down all of it. And then 1 minus 0.2. Now you could do that in Desmos as well. That's going to turn out to be 0.80. And then your exponent is to the nth power. Once you get it to there, then your next step is to use a logarithm. So n equals, and we're doing log the base is the 0.80, and you're doing the log of this decimal, 0.32558. All right, so remember that Desmos has a button that you can use for that. So you can go to the keyboard. I need to move that so I can get to the keyboard. And then functions, go to miscellaneous and the log. Whoops, I need to clear what I had before. So functions, log. Remember the base was 0.80, and the decimal, and I've forgotten, I'm going to go look, is 0.32558. So 0.32558. And we have 5.03. We'll see what it wants us to round to. Round to the nearest tenth. So going back here, that would be 5.0. The 2 would keep it at a 0. So 5.0 for that rounding. And you may be asked to round it to the nearest whole number. And sometimes that means that you have to round this up even when it doesn't appear to do that. If it takes more than 5 years, even by a decimal amount, then they may want you to realize that that would be 6 years to get the job done. So you'll have to do some reading and maybe some checking on what you need to round it to. So there's your first example. The next formula that we are going to look at is appreciation of interest. This is the compound interest formula. And so you'll see that you have these variable descriptions. Probably the one that you might have the most question about is the investment period. And when you hear of something being invested semi-annually, that means twice a year. Quarterly is 4 times a year. Monthly, 12 times a year. And daily, 365 times a year. So we have a story problem here where the grandparents put $5,000 in a savings account. It earns 6% interest compounded quarterly for a college fund. They want to know how long it would take for the amount to triple. So the starting amount of money is the $5,000, and the rate is the 6%. Now, as a decimal, we'd have to put in a 0, so 0.06. The n you're going to need to get, because it is compounded quarterly. So quarterly is 4 for the end, excuse me. And then the A, since it wants to know how long it would take for the account to triple, we need to take P and multiply it by 3. So 3 times your value for P, which was 5,000, and that's going to give us 15,000. So in solving, we'll have A, which is 15,000, equals, and then P, which was 5,000, times 1 plus, and then it's, if we go back and look at your formula, it's R over N. So this is a little bit different formula. R, which is 0.06 over N. N was 4 because that was compounded quarterly. And then your exponent is N, which again is 4, but it also is T, 4T. So that will be our unknown amount. Well, the first thing we'll do is divide both sides of the equal sign by the value for P. So we're going to divide by 5,000. And so this will give you, if you take 15,000 divided by 5,000, you get 3. We can add this up now. You may need to do that using Desmos. So 1 plus 0.06 divided by 4 gives you 1.015. You definitely do not want to round on that. So 1.015 to the 4t exponent. And then now we'll need to use a logarithm. So your exponent 4t equals log. The base of the logarithm is the 1.015, and you're doing the log of 3. So now to have your best shot at getting an accurate answer, you may want to go ahead and do all of this at once. To get t by itself, you're going to need to take that answer and divide by 4. So you might want to go ahead and just type in all of this at once. Log base 3, it's log base 1.015 of 3, and then divide by 4. And that will give you your answer for t. So if we go into here and we do the log base 1.015 of 3, and then divided by, hopefully it'll do the whole thing, make sure it does, divided by 4, we get 18.447. We'll look to see, they want us to round to the nearest tenth. So the 4 after it keeps the 4 where it is. So 18.4 years is how long it would take. So t is 18.4, 18.4 years. So you may have some trouble with the rounding. Be sure you read the question. Be careful to copy down several decimal places. Don't round your answers too early. The best bet would be to write down all of your decimals. All right. Thank you and good luck with your homework.